So let's look at this problem here. So we know 3 different methods for solving a quadratic equation now. We know factoring, right? We know square root property, taking the square of both sides. We know completing the square. And we know the quadratic formula. Alright, so when you solve a quadratic equation, you basically need to pick the one that you think is most appropriate. Alright, sometimes taking the square root of both sides is easier. Sometimes quadratic formula, sometimes factoring. You kind of go with the flow, right? There is, it's just sort of based on case by case situation. So let's look at these problems and figure it out. Okay, so part A says we have 5z squared equals 17. Right? Now this one, because you just have the z squared, this would be easiest using the square root property, because you can easily, you can divide by 5 and get the z squared by itself, 17 over 5. And then I can take the square root of both sides with that plus and minus, cancel it out, and you get the solution. I have z equals plus or minus square root of 17 over square root of 5. I'm going to rationalize, and we get z equals plus or minus square root of 85 divided by 5. Right, so this seems to be an appropriate method for that kind of problem where only the z squared terms, or the squared term, appears. Let's look at part B. Okay, so part B, we have 4x squared minus 12x squared plus 9 is 0. Right. This one, I would not use the completing the square because I would have to divide by 4 and you get like messy fractions. I would try to factor it. Okay, so let's see if we can factor this. This is 2x minus 3 and 2x minus 3 equal to 0. 2x minus 3 squared equal to 0. So we get 2x equals 3, or x equals 3 over 2. Right? So here we go. Factoring seems to work pretty straightforward. You could do the quadratic formula, but that's a lot more steps, right? So you can see that it factors, you go factor it because it's a lot quicker. All right, let's look at C. 8u squared plus 6u is 11. Again, I wouldn't use completing the square because I would have to divide by 8 and I have all these messy fractions. So I'm going to put everything on one side, minus 11 here. Factoring, it looks ugly. So I'm going to jump into the quadratic formula. Negative b squared plus or minus b squared minus 4ac divided by 2a. Right? So this quadratic formula is appropriate here because the other methods look uglier. Right? So we have negative 6 plus or minus 6 squared minus 4 times 8 times negative 11 divided by 2 times 8. Negative 6 plus or minus 36 plus 132. No, that's not right. Let's do it with my calculator. 4 times 8 times 11. 352. Divided by 16 gives me negative 6 plus or minus square root of 388 divided by 16. Alright, let's see, 388, I don't think that's a perfect square. No. But it simplifies. That's negative 6 plus or minus square root of 4 times square root of 97 divided by 16, negative 6 plus or minus 2 square root of 97 over 16. Factor out a 2 on top, negative 3 plus or minus square root of 97 over 16. Cancel out a 2, and we get negative 3 plus or minus square root of 97 over 8. Alright, and when you get square roots in your answer, this would not have factored anyway. It would have been prime. Alright, and that's it for this problem.